All right, today we're going to talk about rotational kinetic energy. And if you recall, we've talked about kinetic energy before, but it was when the object was moving in a straight line. So this was translational kinetic energy that we talked about previously. If you remember, we said in order to have kinetic energy or translational kinetic energy, the object had to be moving. I have to go ahead and look at this equation, all right, which is 1/2 mv squared. So the object needed to have a velocity, okay? And in this equation it was actually speed because we weren't concerned with which direction the object was going, just that it was moving, okay? And then we have the inertia of the object, which is its mass, when we're talking about translational motion, okay? So we've got this equation, and it was measured in joules. We're going to go ahead and relate that to what we are now talking about with rotational kinetic energy. Okay? We're still going to use the symbol kinetic energy. We're just going to put an ROT underneath it so that we denote that it's for rotational. And the equation is going to be very similar. All right? It's 1/2. But instead of the inertia of the object, we need to use the moment of inertia for the object. And instead of the velocity in meters per second, we need to use the angular velocity in radians per second. Okay, so it's very similar to what we had before, still measured in joules, but the object in this case, instead of needing to be moving, needs to be rotating. Okay, and when we substitute in order to get our kinetic energy to be in joules, we need to make sure that we use some base units: radians, seconds, meters, kilograms. So let's go ahead and just take a look at our notes page here. Rotational kinetic energy is the energy caused by a rotating object. Okay, so in order to have rotational kinetic energy, the object must be rotating. It is a scalar. That means we don't worry about the direction. Okay, the symbol is kinetic energy with a subscript ROT. The units are joules, and the equation is the rotational kinetic energy is equal to 1/2 the moment of inertia times the angular velocity squared. So let's take a look at a couple of things here. We have this girl playing with a yo-yo, and maybe the yo-yo is just spinning around down here. Okay, so it has rotational kinetic energy. But if it's also moving along, it then has translational kinetic energy. So an object could have more than one type of kinetic energy. Another thing here, we've got Earth spinning around its axes, okay, but it's also moving and orbiting around the sun. So this object has both rotational kinetic energy and translational kinetic energy.